Now, let me explain what they mean by faster and slower mediums. Right now, when we're done with class and you're out of here, you're going to either go down the stairs, you're going to go down the elevator, whatever it is, but you're traveling through a medium called air. Now, imagine if we put you inside a swimming pool that's 5 foot. Now, how fast can you walk the same speed through water as you could through air? No, those are two different mediums. One is faster and one is going to be slower. Why? Because the density is different, okay? That's the reason why one is faster and one is slower. All righty, turning the page. Again, like I said, there's a couple of things. Do you remember this question right here on the quiz where you had a label? This is the same thing, but it has to do with refraction. This one was reflection. So you're going to have this guarantee. It's going to look like this, where you have to do a labeling regarding an image. So here's an image, and let's go ahead and let's look at the labeling. It says here, the normal line, it's almost always a dotted dash line. But remember, in that picture, it was a solid line. Now that line is always going to be 90 degrees or perpendicular to the surface. So here's my normal line, here's the surface, perpendicular forms a 90-degree angle. It says here, though, here's our new thing. We've got a theta I, and we also have a theta R. We're going to have a NI and an NR also in just a moment. Now, my theta I is going to be my angle of incidence because it's going in it. And it's going to be where it's going to enter. And my theta R is my angle of refraction, where it's going to bend out or come out of it. So when you look at this one over here, I've got my light that's shining in. It's coming in right here. This light is being reflected out. But this light is passing from the glass to the air, and it's going to refract or bend. Here on this portion, this side right here is my theta I, where the light is going in, and what happens? It always touches the normal line. My theta R, which is right here, again, is where it's refracting, but it's still touching the normal line. So all of this other stuff we're not going to use. Don't get tricked on that later on next week. It says here that the index of refraction is going to be our first equation. We have 3 equations for these notes. The first one is called index of refraction. Lowercase n equals C over V. Now, we actually know C already. Lowercase c is the speed of light. V just means the velocity of anything. It's actually going to be the speed of light in a particular medium. And n is going to be one of these numbers right here. We call that the index of refraction, okay? So n is the index of refraction, and the smallest it could be is a 1. We can't go less than 1. I mean, I don't know. Time travel, going through a black hole, bending around a black hole, I don't know. It's got to be something crazy like that. But at this moment, we do not know anything less than 1. 1 is the smallest number. C is the speed of light, which is 3 times 10 to the 8th meters per second. And V is the speed of velocity in the new medium. I mean, it could be 2.22 times 10 to the 6th power. I don't know. Whatever it is, it's going to be another number. It's going to be another number like this, but it's going to be a different one. Now what happens is the index of refraction is a ratio of the speed of light in a vacuum compared to the speed of light in a different medium. Okay? How fast light can travel. Well, the cool thing is we live here on Earth and we have this atmosphere that we breathe, but it's not really thick. And because it's not thick, light actually travels pretty much the same speed here as it does in outer space. So we consider the speed of light through air to be the number 1. Remember what I said. The number 1 is the fastest and the smallest number it will go. The number 1 actually represents the letter C. The speed of light through air, we consider it to also be the number 1. It's very small of a difference. It says here, remember the speed of light in the vacuum is pretty much the same as the speed of light through air, which we consider to be 3 times 10 to the 8th meters per second. Okay? It's not exactly, but it's pretty close. And you can see in my chart, the speed of light, or the N number, is 1.000293. Very small difference. It's so little that we don't even consider it. We just consider it to be 1. We consider it to be 1. It says here that the index of refraction, or the NR, for air is considered to be 1.00, just as if it was considered to be the same through outer space of vacuum. The index of incidence, NI, for air, let's just say, is also 1.00. Because why? Light doesn't bend much. When light is traveling through our atmosphere, and I don't mean a cloudy day, and I don't mean through rain sprinkles and now we have a rainbow, okay? I mean like it's a super clear day, kind of like yesterday when the shuttle went off. It's a super clear day in Florida, that light just goes in a straight line. It really does. How much? This little it bends. Almost insignificant. Okay? It says here, though, the larger the index of refraction number, the slower the light is going to travel. Meaning, I don't know about you, but if you want you a nice diamond, a nice gemstone, you want it to be pretty high in these numbers. This is 1.9, 1.5, 1.49, but a diamond is 2.4. That's because when light goes into a diamond, it is going to cause some major refracting, and that's why our pretty diamonds shine and sparkle so much. Okay? It says here, though, smaller index of refraction is going to be when the light travels faster. It's not going to bend so much. It's not too thick. Remember, the smallest is 1. When NI is greater than NR, light is going to bend away from the normal because it is moving faster. When NI is less than NR, light bends, I can scoot it up, towards the normal, and which means that it's moving slower. I would reread this again later on. Let your brain rest and go back and read it a couple of times. I would also say, you know what, Miss Munson, thanks for the notes, but I'm going to go YouTube a video or something or an image. I mean, there's only so much I can do. You've got to go and kind of do a little bit of research. I would go and Google, AI, right? I need a picture of NI greater than NR, and I need a picture of NI less than NR. That would come in handy. Find a picture. Put a little note, find a picture, okay? Because it's going to help you out. But I will go over that before, and I'll draw a picture for you before we take the quiz. All righty. Now, that was a super easy, cheesy equation. I am going to come over here to equation number 2. So that means everything above this, I'll post on D2L today, this afternoon. Equation number 2 is not really that bad, but I get some students who freak out. So we're going to practice on the next page in just a moment. It's on the formula chart, so don't freak out. Ni times the sine of theta I, oops, that should have been an I, equals NR times the sine of theta R. Okay. Ni times the sine, oh my goodness, are you serious? We're going to go back to a sine? Well, it's sine, not cosine, not tan. And I'm going to write myself a note right here. Should be in degree mode. I'm just going to write myself a note. I should be in degree mode. I must. I have to. I use the word should, but again, you do you. It has to be in degree mode if you want the correct answer. Let me say that. Because we're actually using the sine, the actual theta. Okay? Let's go ahead and let's keep going over here. Ni, which is right here, stands for the index of incidence. And it's going to be our first medium. The sine of theta I is going to be the sine of the angle of incidence. And don't forget, it always touches the normal line. The NR is the index of refraction. And it's going to be when it's going through the second medium, because it's going to refract, it's going to bend. Whether the second medium is thicker or thinner, it's still going to bend. The sine of theta R is the sine of the angle of refraction. How much it bends. Again, though, it's going to touch the normal line, right? It's going to touch the normal line. Well, right above it, you can read, it says here that it's actually called Snell's law. It's a pretty popular equation we use in physics. We use this in microscopes and telescopes and, all types of different things with lenses. Our own glasses as well. The next equation is really one that we use for our personal vision, or our eye doctors use the next equation all the time. So now Snell's law is going to determine the angle of refraction. It can actually figure out what the angle is going to be. If you know what you want it to be, or where it's coming from to where it's going to, and you have one theta, because there's 1, 2, 3, 4 variables, all you need is 3 variables to solve for the 4th one, okay? So it says here, Snell's law is used to find the angle of refraction for a light that's traveling through two mediums. Okay? Through two mediums. Not three, just two. Okay? And so again, it can go from something thick to something thin. Something thin to something thicker. From air through jello. I don't know. Whatever you want it to be. Now we're going to turn the page and we're going to practice this. Okay? We're going to do two practice problems right here. Now we're going to need that chart because we need that N number. That N number is going to be determined by the material that it's going through or it's going through currently or going to go through. It says here that a light is traveling at 589 nanometers lambda. It's going through air. Whoa. In physics, words have number value. How do I know? Look right here. Air. And not only that, but forget all those last three numbers. Let's just call air 1. That's too much. We're not going to go that far in digits. Ni equals 1. Okay? Then the light is going to go through this glass called crown glass. Oh, let me look at my chart. Crown glass is right here. 1.52. NR, or N2, equals 1.52 at an angle of 30 degrees to the normal. The sine, I'm going to pause for a moment. Find the angle, question mark, theta, or this can be a theta, of refraction. If this is theta r, this is theta I. If that is theta r, then that has to be theta I. Alrighty, I'm going to write down the equation for you right here. And I times the sine of theta I equals NR times the sine of theta r. 1, 2, 3, 4. We've got 4 variables. Okay, 1 times the sine of 30 degrees equals 1.52 times the sine of the theta I don't know. Okay, like algebra, if these two numbers are being multiplied, then I have to do a division. Cancel. Division. Okay? The sine of the theta equals 1 times 30. The sine of 30 degrees is 0.5 divided by 1.52. 0.33. 0.33. Got your phone out. Jordan, we're going to pick on Jordan. Jordan, is 0.33 correct? I saw Logan pulled out his calculator. He pulled out his little fancy blue one over there. And I know you have a fancy one that Grandma got you.
Yep.
Yeah, I know you do. Don't make me have to call her.
Grandma got all of these.
Yeah, she's tired of your crap. That's because I called her.
Oh,
You know I be calling y'all kids and I leave the messages. Grandma
Yeah.
too.
Grandma too.
Grandma too, yeah. I don't mind.
Don't you need to find the, or do the inverse sign?
Why are you giving him the answer?
Let me make sure
This
he
was the
agrees.
test to see if he was gonna be in your group or not. Ugh. Go ahead, this time. Oh, he's trying to make sure he's in degree mode. Uh-huh. Well, Logan already cheated and told you .33 is not the answer, which is not, it's not the right answer. Because we're actually looking for the theta itself. Remember this from last semester? Mm-hmm. Oh, yeah, okay, we're about to get on your phone and call her next. She about to, oh, man. Whew. Okay, that's not the right answer. But your buddy over there, Logan, says, what do you want me to do with my calculator? What do you want me to push?
So, I don't know about that one, but do inverse sign.
Inverse, second key sign. Remember that negative button?
And then do 25 over 76.
19.3. There you go. There goes your answer. Do you remember that? I hit second key sign because I needed that little negative button right there. If we remember those negatives. And so it's the inverse is what Logan says, the inverse of sine. So it actually comes out to 19.27 degrees. Give or take, 19.3.
19.205.
205. All of those are good numbers. Let's practice again. All right, this I guarantee you is on the quiz. They're all equal point values though. Find the angle of refraction. Question mark theta r for the light that enters a bucket of water in, wait a minute, from air in I in R. That means it goes from air, which is in I, which is your first one. In R is your second one. All right, air is 1. What is water? Look at my chart. Here it is, 1.33. At an angle of theta I, 25. All right, let's do this again. Same thing. I is 1 times the sine, oops, right here, of 25 degrees. Equals 1.33 times the sine of theta. I don't know it, but just for those of us, I'm going to do a little inverse sign to help you out. Divide by 1.33, cancel. Divide by 1.33. Fancy calculator out. The sine of 25 divided by 1.33. My answer is not 0.32. That is not correct. What is it?
I got 18.66.
That sounds good to me. $18.7, 18.5, all of those are good. We cannot forget to use our fancy calculators for this one. One more equation, and I promise you we are done. I promise you. I know today is a mind-exhausting day, and I apologize. When you're ready, turn the page. Okay. The next equation, actually, when you go to your eye doctor, they do this one all the time. Okay? Not only that, but, where is it? When you look at your eye paper, your prescription for your eyes, you might probably actually even see some of these numbers, because the eye doctor needs this stuff. So that way they can figure out where to put your glasses on your face and where they're gonna have this prescription located at, so that way you can actually see. Oh, I have my prescription. Just, I don't even know if you wanna see it, it's getting pretty rough. I'm getting old. I had to get old people glasses now, that's how old I'm getting. But I do want to show you, because those of us, number one, who actually wear glasses, or for those of us later on, you may not need glasses now, but there's a good chance you're going to need glasses when you're older. So first question, Mr. Jordan,
Yes, ma'am.
those glasses that you have on your face, how long have you been wearing glasses?
Something like 5.
Ooh, me too. Okay, next question, Jordan. Have you always had the same prescription, or have they changed it when you were younger, like 5, 6, 7, 8, 9? They changed it. Okay, now that you're a little older, have you had the same prescription for a while? No?
It changes every time.
They change every time. All right, I will tell you, when I got in my mid-30s, my mid-20s to my mid-30s, that was it. I haven't changed my prescription for about 12 years straight. Maybe even 15 years. I had the same prescription. Well, that's because when we open up those eyeballs that Miss Waddy ordered for us, those eyes are going to be juicy. So when we open the eyes, Kim, when you open up those eyes that are really juicy, there's a fluid inside our eyeballs. I don't know, for those of you who wear contacts and you can like touch your eye, you can like, your eye is squishy, right? When you get younger, your eye is a little smaller. Believe it or not, that amount of liquid in your eye grows with your eyeball, because you're a little kid and you grow. Does that make sense? So your eyeball is going to continue to grow. That's the reason why your vision changes a lot when you're younger. Then when you get in your 20s and 30s and 40s, you kind of stay the same vision, because your eye, you don't grow no more. I haven't grown. I mean, I've been this height since I was in high school. You know what I mean? Like, I haven't grown anymore. But when you get older, believe it or not, remember how we talked about hearing starts to go bad? Your eye starts to decrease the liquid in it again. And when you get like 50, 60, 70s, now you need to start getting a lot of glasses or changing them again, because, what do you call it? Because your eye is losing liquid. This equation right here is going to determine where I need to put these glasses on your face so that way you can see that object. I wanted to see, but they call it a DO and a DS here. We actually, on our equation, it's called 1 over DO. Oh, looks a little familiar from those glasses prescription. Plus 1 over DI equals 1 over F. And I'm looking at this prescription and I don't see an F. It should have an F on here. That's okay. Here we go. Over DO equals the distance from the object to the lens. I'll show you what I mean in just a moment. 1 over DI equals the distance from image to the lens. And then the F, which is lowercase, not capital, stands for focal length. Okay? Focal length. Now, we already kind of did this one thing, this drawing. Do you remember this drawing? This is actually, pretend this is your eye. You are looking at this direction at the actual object of a pencil. But behind, and some of us have to wear glasses right here. Look, light is gonna pass through my glasses and it's gonna form an image in the back of my eyeball. Well, guess what? You're blurry to me. So I've got to put on these glasses so when I'm looking at this object, it can be focused, focal length, at the right spot so this image can be nice, crisp, and clear. Okay? That's what this equation is over. Alrighty? With that said, let's practice it and I will leave you alone. An object, D-O, object, in front of a lens has a focal length, F, of 12 centimeters. Find the DI, or the image. Where is this image going to be located at? All right, so number one, centimeters, centimeters. Leave them alone. Don't try to convert. Since they're both the same, leave them alone. If they're different, then convert somebody. But since they're the same, you're going to write them in the equation. 1 over 20 plus 1 over DI equals 1 over 12. Okay, the cool thing is you have these super handy dandy fancy calculators and you can make a fraction, right? You can do the top number and the bottom number. So you can put this equation into your calculator. Me personally, I just don't. But I don't want to force you to do the math the way I do it. You can do it your way. So I would super appreciate if Logan can type it into his calculator like this, into a fraction format in a moment, and then I'm going to show you how I do this. But the number one problem that I see students is the last step. So let's go ahead and do this. 1 divided by 20. Why? Because we don't like fractions in physics. 0.05 plus 1 over DI equals, I don't like fractions, 0.083. 0.083. Okay. This is an algebra problem. That's all it is. I need to get DI by itself, but I have this addition. Do you agree? Subtract it? Let's do that. So what I'm going to do, I'm going to come over here, and I'm going to subtract 0.05, subtract 0.05. That cancels. 1 over DI equals 0.083, take away 0.05. 0.0333. Once you do yours, I want to know what you get in a fraction format.
1 over 30.
Oh, 1 over 30.
Yes.
Okay. Okay. 1 over 30. He got 1 over 30.
Which is the same answer.
Which is, because if you typed in 1 over 30, still wrong. Still wrong. Okay, so just saying, if you go this route and say, you know what, I got this fancy calculator and I'm going to type this equation into my calculator and I'm going to get 1 over 30, guess what? You're still getting the wrong answer. There's a problem. I need your algebra skills to come back and play. Where is my unknown variable? At the bottom of the division. So I agree, 1 over 30 is okay, but you're not done. What do you need to do with the unknown variable at the bottom? Get it to the top. How? Multiply or flip them. Okay? So I like to do the reciprocal, meaning this number is truly over 1. If I just flip this number, I must flip this number. So if I say DI over 1 equals 1 over 0.0333, now give me your answer.
However,
Yes,
if you do it with the fractions,
correct.
because it's 1 over DI and 1 over blank,
Yes.
you just take the bottom of the thing, put that as the answer.
Oh, okay, and then you would get it.
30
30 would be your answer. Exactly. Did you get 30 though on this one? You got 30? I got 33. So 30 centimeters or 33, whatever you got. But this fraction is not okay. There you go. Not okay. Easy? It's a little weird. It's a little weird. Can you practice this in the next 3 days maybe, please? Other than that, seriously, have a good